Hello, so today we will define trigonometric functions using unit circle method. Next section will cover trigonometric functions using right triangle approach. Objectives are, we will first describe what is a unit circle, and then how do we define the trigonometric functions on unit circle, how do we evaluate, and then what is the domain and period for sine, cosine functions, so on and so forth. So what is a unit circle? Well, unit circle, it's placed on x, y coordinate with origin at the center. And why do we call it unit circle? Because the radius is equal to 1. Okay, so now let's define trigonometric functions on unit circle. Well, first we need to we need to recall angles, right? What is an angle? Well, for trigonometric purpose, for trigonometry, we always place our initial side of an angle to the x-axis, and its vertex or endpoint is 0, 0, origin, right? And then if you move to the counterclockwise direction, like in the first one, then we have theta positive, right? If you move on the negative or clockwise direction, we assume theta is negative, right? That was the definition. Now let's say that I had this my initial side, and then I moved it by, or I rotated it by theta angle, and I stopped right here, right? Originally I started from 1, 0 coordinate, and then I stopped at xy coordinate, and I have this angle theta. If that's the situation, then what I call sine of t, is my y. So what is t? T is in here is simply a theta, okay? Because of this arc, right? For the unit circle, if you remember, what is theta? Theta is arc length, right? S divided by the radius. But what is S in here in this situation? S assumed to be t. R, its unit, so it is 1. So basically this whatever arc you see is the same as the angle, right? So this sine of t is the same as sine of theta. So that's my y. What is y? Y is just the y coordinate, right? It's this y coordinate of this angle. And cosine of t, it's x coordinate. What is tangent of t? It's y coordinate divided by x coordinate. And the cosecant, this CSC stands for cosecant, is 1 over the y coordinate. Secant is 1 over x coordinate, and the cotangent is x over y. Alright, so with this definition, so these are sort of the 6 trigonometric functions that are the building blocks of the trigonometry, right? So now there are some very special angles for which we should define this trigonometry, right? And in most cases it's better to sort of memorize, because in many calculations they appear, so if you memorize it becomes handy. Alright, so let's for this again. So what are these functions? These functions are related to the coordinates, right? This xy, right? These coordinates, xy coordinates along the circle. Once I rotate my angle to theta, right? Okay, so which means I should be able to determine some of the coordinates, xy coordinates on the circle. Some of them are easy, some of them are not so easy. So let's look at the first one. So okay, so this is easy, right? This is 1, 0. right? So for example, what would be sine of 0? Well, it's the what is it? It's the y coordinate, right? This is the y. But what is y coordinate in here? It's 0, right? So that's 0. And for example, what is the cosine of 0? Well, cosine of 0 is my x coordinate in here, but its x coordinate is 1. So here it gives me 1. And so on and so forth, right? So once you have those values, it's easy to calculate. But okay, so this is easy. That's also easy. This is 0, 1. This is negative 1, 0. And finally, this is 0 and minus 1. Now, if I look at the 45 degree or pi over 4 or 45 degree here, right? 45 degree, if I split as such, so all the 45 degree, right? So all are equal. So what I'm doing, I'm splitting the circle into 8 equal pieces, right? So each one is going to be 45 degree. Then this point, this coordinate in here is going to be square root of 2 over 2, comma square root of 2 over 2. Well, why is that? Well, okay, so what is, if you think of this as a line, right? As a line, what is this? This is just y equal to x line, right? And then look at this. What is this point? This is the point on my circle. But what is the equation of a circle? It's x squared y squared equal to 1, right? But since y is equal to x, I can just replace y by x squared. So it becomes y squared by x squared. So it's x squared plus x squared equal to 1. Well, that leads to 2x squared equal to 1. Well, that leads to x squared is equal to 1 over 2. So which means if you solve for x, so x is going to be plus minus 1 over square root of 2, or plus minus, you can rationalize the denominator, it's square root of 2 over the 2. But since I'm on the first quadrant, right, this is my first quadrant, it's going to be plus. So that's how you get x, but since x is equal to y, you get the other square root of 2. And by symmetry, now you can see that this is minus square root of 2 over 2, comma square root of 2, and so forth. Okay? Now, another instance, so these are important, right? 45 degrees. So 45 degree, you remember, it's pi over 4, right? Okay. Another interesting case is when you split the circle into 12 equal pieces. Well, so 360 degree, right? If you divide into 12 equal pieces, you get 30 degree, right? So that's my pi over 6, right? It's pi over 6. So which means each one is pi over 6 or 30 degree, right? 30 degree. Each one is 30 degree. So yeah, if you work hard, probably you will find out that these coordinates are as stated in here. So for example, here this is x coordinate is square root of 3 over 2, comma the y coordinate is 1 over 2, so forth. Okay, so in fact, if you determine one of them, then the remaining parts, again, like symmetry. For example, here you see this is symmetric to this point. That's why this is x must be minus. Here it is, this is like opposite direction. That's why both of them should be minus, and so on. So basically, once you determine one of them, you can determine the others by symmetry. But so basically, this is what's very important. So for example, right? For example, what is sine of pi over 6? Again, this is y coordinate, right? It's y coordinate of this, which is 1 over 2. For example, what is cosine pi over 6, right? What is it? It's the x coordinate of this angle. So this is square root of 3 divided by 2, and so on, so forth. Okay? So basically, once you know these values, it's okay. Life becomes easy. So let's do example. Evaluate 6 trigonometric functions at each real number. So I again copied those important circles. Yeah. So I don't want to do all of it. I mean, especially for all 6. Okay, we'll try. Let's try some. So let's start with A. So Remember, again, what is sine of t or theta? What is sine of t? It's y coordinate, right? So pi over 6 is here, pi over 6 is here, so it's the y coordinate of this, which is 1 over 2. What is cosine of t? It's the x coordinate, so this is x coordinate is square root of 3 over 2, right? Okay, what is the tangent of x? It's the well, you can remember it at sine over cosine or y over x, right? Sorry, here it should be t. So y over x. So if you divide 1/2 by square root of 3 over 2, you get 1 over root 3, or you can write it as also square root of 3 divided by 3. Okay, cotangent is the when you flip the tangent, right? It's the inverse of the tangent, so it's x over y. Well, this is, now you divide square root of 3 over 2 by 1 over 2, right? So it becomes square root of 3. How about cosecant? Cosecant t, it's 1 over y, provided y is not 0. But what is my y? It's 1 over 2, right? So this is 1 over 1 over 2, which is simply 2. What is the secant of t? It's 1 over x. My x, provided x is not 0, so it's square root of 3 over 2. So this is 2 square root of 3, or 2 square root of 3 divided by 3. Okay? Right. So let's try b. 5 pi over 4. What is it? Well, 5 pi over 4, you can also write it as pi plus pi over 4. Pi over 4 is 45 degree, right? So which means you're adding pi, so we know that pi is right here. You add 45 degrees, so you get here, right? So that's the, so this is the your xy coordinate. So both of them are minus square root of 2 over 2. So for example, again, similarly, sine of t now, sine of t is, it's y coordinate, so it's minus square root of 2 over 2. Cosine of t, or 5 pi over 4, whatever you call, it's also minus, it's x, right? It's x, or 1 if you want, okay. It's minus square root of 2 over 2. Now, tangent of t, this is x, y divided by x, so this is 1. Well, cotangent is also 1. Cosecant of t, it's 1 over y, so this is minus 2 square root of 2, or if you want, it's minus square root of 2, and the secant of t is 1 over x, again it's minus square root of 2. Let me do one more. So I will leave t equal to pi for you, but let's do t equal to 0. So t equal to 0 is right here, right? The angle is 0 means it's, I haven't started, right? It's right here. So it's x coordinate is 1, y coordinate is, so x coordinate, so for d, so x coordinate is 1, y coordinate is 0. So then sine of 0, it's 0, cosine of 0, it's 1, tangent of 0 is 0, cotangent of 0 doesn't exist, right? Let's call it dn. Why? Because you cannot divide by 0. So cosecant of 0 is 1 over y, but y is 0 again, does not exist, right? Doesn't exist. But secant of theta, that's 1 over x, x is 1, so this is well defined, and so on and so forth. Okay. Evaluate 6 trigonometric functions at t equal to minus pi over 3. So pi over 3 is 60 degree, but you need to move on the negative direction, right? Okay, so let's try to find what it is. Basically this means you rotate clockwise direction to 60 degree, and if you look at the circle, you see that this gives me the coordinates 1 over 2 and minus square root of 3 over 2. So then sine of t, which is just y, which is minus square root of 3 over 2, cosine of t, it's x, it's 1/2, tangent of t, that's y over x, so you see minus square root of 3, cotangent of x or t, it's 1 of the tangent, okay, it's minus 1 over square root of 3, cosecant t, it's 1 over y, so it's minus 2 over square root of 3, and finally secant of t is 1 over x, so this is just 2. Alright, now how about domain and range? Well, what was the domain? Domain is, we look at when we sketch, right? So we look at where the function is defined, right? Well, okay, so my angles, right? So if I rotate counterclockwise, I can rotate like this until 2 pi, but I can continue, right? I can continue rotating this way. So it means any positive number is domain. Or if I rotate clockwise, I can cover all the negatives, right? I can keep rotating, so it gives me all the negatives. Hence, my the domain is R, right? So it's all real numbers for sine and cosine. But we already saw, like for the others, like tangents and cotangents, secant, cosecant, provided like x or y coordinates are not 0, right? Depends. It depends. So if you avoid those cases when the denominator becomes 0, they are also defined almost all real numbers. Okay, how about the range for sine and cosine, right? So what is the, so again, remembering that sine of t is y, and we see that because our values are along the circle, we see that my y values varies from -1 to 1. Similarly, my cosine t is x, my x values varies from -1 to 1, right? So which means for both sine and cosine, the range of these two functions vary from -1 to 1. If you wish, it's like closed interval, -1 to 1. Okay, how about periodicity? Because the trigonometric functions, especially sine, cosine, they are periodic functions, and that's why they find lots of interesting applications in real life. Okay, especially if I want to model things with periodic systems, right? Okay. So what is a periodic function? A function f is periodic if you can find some number, it could be positive or negative, such that for any t, for every single t, we have this f of t plus c is equal to f of t. The smallest c for which f is periodic, we call it a period, right? So let me try to sketch. So let's say that you have some sort of a function, maybe it could be somewhat linear, could be, right? And then it kind of repeats itself, right? So for example, value at this point is the same as value at this point. And then it repeats. The value at this point is the same as value at this point, right? A value at this point is same as value at this one. So basically what we see is whatever this distance is, right? If we call this C, so that's going to be the period, right? Because if I look at, let's say that if this is 1, this would be like 1 plus the C, right? So it repeats. So once I shift it by C units, the graph is not changing. That's what periodic means. Well, how about sine and cosine? In fact, for others also. Well, they have the period 2 pi. Why it's 2 pi? For example, let's say that I'm interested in here, right? Let's say this is pi over 4, right? It's pi over 4, right? Okay, so let's say that I calculated this sine pi over 4, right? But if I make a full rotation plus pi over 4, right? If I sort of come back to here again, but after full rotation, what do I get? I get the same coordinate again, but now I have different angle. What is the angle? It's pi over 4 plus the 2 pi, right? So if I take this sine of this, it's the same, because once I come back to the same angle along the circle, right, after one repetition or rotation, I arrive to the same y coordinate. That's the sine, and the same level for cosine, x coordinate, right? So that's why basically the value of this coordinate at pi over 4 or pi over 4 plus 2 pi or pi over 4 plus 4 pi, etc., they are all the same. So which means my C from the previous definition, if I take it to be 2 pi, my sine function, my cosine function, they will be periodic. Okay, so you can try to sketch the graph, or you can use the calculator or look up from the Google, and you will see some shapes like this. Yeah, right. Anyway, so it looks like, okay. So basically, it sort of repeats itself. Okay, so there is some 2 pi. So this will be like sine of t or sine of theta. Okay. Right. So that's what we mean, right? So sine t plus 2 pi n for any integer n. It could be also minus, right? Because you can also do negative rotation. So you can start from here, you can rotate like this, you come back to the same point. So again, you can go to the minus direction. So n could be negative. So regardless of n plus and minus, as far as it's integer, so we see that we have this periodicity. Okay. Cosine and secant are even functions. So if you remember, even function means if you replace t by minus t, you will get equivalent function, again, the same function. On the other hand, sine, cosecant, tangent, cotangent, they are odd functions. And recall, what is the odd function? Odd function means if you replace t by minus t, you get minus of the function, of the original, right? So here it's minus. Okay? All right. So let's calculate these two values for sine and cosine. So 13 pi over 6, sine 13 pi over 6. Well, what is 13 pi over 6? 13 pi over 6, I can write it as 2 pi plus pi over 6. Right? Now, I can use that the fact that sine is periodic with period 2 pi. This is the same as sine of pi over 6. But sine of pi over 6, or sine of 30 degree, is 1/2. Okay. How about cosine minus 7 pi over 2? Well, how I can sort of rewrite this expression? There are many different ways, but one approach is I can make it like minus 4 pi plus pi over 2, right? because 2 times minus 4 is 8. Adding 1 will make you minus 7. But again, this minus 4 pi is 2 times the period, so because of this periodicity, this is the same as cosine of pi over 2, right? But what is cosine pi over 2? Cosine of 90 degree, right? So this is 0. It's the x-axis of this 90 degrees.